Hello, everyone, and thank you for joining us on today's Sparring Partners webinar. Will Open RAN increase power efficiency in the RAN? Our speakers today are Alex Choi, Senior Vice President of Deutsche Telekom and Chairman of the O-RAN Alliance, Gorden Witzel, Senior Partner Manager, Vendor Strategy Access at Deutsche Telekom, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners webinars, we watch our speakers debate a topic live on video. We would like to encourage our audience to participate in the conversation. Please share your comments and questions using the Q&A and chat functions in the Zoom taskbar. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed. So please do not hold your questions until the end. And with that, I'll hand it over to Monica.
Kendra, thank you so much for the introduction. As always, it's a pleasure to be here. And today we're going to talk again about energy efficiency. We had two previous sparring partners on this, one with Vodafone and one with Mike Short, and there will be another one with Mark Gilmore, Connectivity Tree, in May 2nd, and the registration will be available soon. Today, we're going to talk about one of the major topics that always comes up when you talk about energy efficiency and when you talk about Open RAN at the same time. And the intersection of the two. Is Open RAN going to be more or less energy efficient than the alternatives? So before I introduce you to our speakers today, I would like to do a poll and ask you what you think about it. So Kendra, back over to you to ask the poll to our participants.
Okay, great. The poll question: is Open RAN going to be more energy efficient than traditional RAN?
And so here, what we would like to hear is what you think before we start talking about it. So we're going to have discussions. Now, here, we're talking about energy efficiency and not energy consumption. And I think as we go along, it's going to be clear what the difference is. Clearly, the two are correlated, but when we talk about efficiency, it's really how efficiently you use the power rather than the absolute amount per se, and that's where things really get more interesting when you think about it. I think everybody voted. So Kendra, can you tell us what the results are?
Yes, we have 43% saying it depends. Open RAN less efficient, 29% said that. 17% said Open RAN is more efficient, and 11% said I do not know.
Perfect. Let me write down a little bit. Okay, so today I have two speakers that have been working on this quite a lot. So we have a lot of expertise, and we will have I think, a very exciting conversation. But as always, we want you to chime in and ask us questions, and we will take questions as we go. And also feel free to talk among yourselves. So with that, Alex, why don't you tell us who you are? Although a lot of people, both of you know who you are, but can you tell us who you are and what is your role within Open RAN?
Okay, thank you, Monica, and also thank you, Kendra. So Alex Jinsung Choi, I'm currently the chair of O-RAN Alliance, and also I'm a senior VP at Deutsche Telekom and leading this Deutsche Telekom research organizations. It's called the T-Labs. So I'm based in Bonn and Berlin.
Gorden, how about you?
Yeah, thank you, Monica. So my name is Gorden Witzel. I'm working out since a long time now already in the radio business. So started from 3G, 4G, then over to 5G, and I'm now 5 years in the vendor management area. So I'm responsible for the access domain, and here I'm working since 5 years pushing O-RAN to get it deployable. So therefore, I'm quite curious about your questions about energy efficiency and looking forward to our discussion today.
Yes, it's somewhat, a complex one. If one thing, just because different people have a different idea of what Open RAN is. So we don't want to get into the deep of the discussion. That would take an hour just to go through that. But maybe Alex, can you tell us, especially since you're working on the O-RAN Alliance, what do we mean by Open RAN?
Thank you,
or
Monica.
what people might mean, or what is it?
Yeah.
What is it we're talking about today?
Yeah. Thank you. Well, so let me make 2 points here. Point number one: let's make sure we are all on the same page about what Open RAN is. So today I will use the definition provided and also published by the UK DCMS last year, which is available. And their definition of Open RAN is based on 4 key principles that are: number one, open disaggregation; number two, standards-based compliance; number three, demonstrated interoperability; number four, implementation neutrality. So let me give you more details. Number one, open disaggregations. What do you mean by that? Open RAN breaks from the idea that a single vendor must provide the entire RAN. So Open RAN, instead, it divides the RAN into functional elements provided by different vendors and connected via open interfaces. So number two principle, standards-based compliance. So Open RAN solution should adopt industry-driven standards for all interfaces to ensure RAN disaggregation is sustainable. And number three, demonstrated interoperabilities. The standardized interfaces and protocols between RAN components are necessary but not sufficient. So the equipment must be demonstrably interoperable in realistic environment. Number four principle is implementation neutrality. So Open RAN should be neutral to the technologies used for implementation and allows for vendor differentiations and flexible approaches to implementing networks in the right mix of hardware and software. So let me make an additional point. The term O-RAN and Open RAN are often used interchangeably, but O-RAN refers specifically to the architecture and specification developed by the O-RAN Alliance that I am chairing now. So while the Open RAN is a broader term that describes a general concept of opening up the interfaces and components within the RAN systems. And now, imagine a vendor comes out of a new, Cloud RAN or vRAN. For me, Cloud RAN is more like following the cloud native architectures. For example, 5G standalone is a cloud native architecture. So when you say Cloud RAN, you mean it's not only virtualized RAN, but it also comply with all these key architectural principles and their ecosystems called cloud native. So the question is whether this solution meet those four Open RAN principles that I just mentioned. If it does, then we could say it's an Open RAN solutions. Despite the fact that vendors tends to prefer their own marketing terminologies, so they may just continue to call it vRAN or Open RAN, no, Cloud RAN, but it's, as long as they meet all four principles simultaneously, it's still Open RAN. But the reality, it might be a little bit different. The vendors, the Cloud RAN, vRAN, may not be able to meet all four Open RAN principles simultaneously. So in some cases, strategically, they don't want to support all of them at the same time for their strategy. In such case, we cannot really call those solutions Open RAN. But there is a case, of course, a vendor has a solution at the moment does not meet all four Open RAN principles, but they should have a roadmap showing that they will meet all four principles eventually. In that case, how do we call it? Maybe we should call it like a Open RAN ready. So to sum it up, the best way to compare these different RAN systems is to look at whether they meet all four Open RAN principles. If they do, we consider it as Open RAN.
Excellent. So what you outline is the fact that it's a really complex issue, and this is why talking about energy efficiency, it's interesting because we're not talking about the impact of disaggregation on energy efficiency, but also of virtualization, centralization. So all of those things get sort of become part of the discussion. So it becomes a very sort of complex question. So what we ask you in the initial poll is a sort of a tricky question, because depending on what kind of aspect you look at, you might be giving a different answer. So Gorden, why don't you tell us a little bit about, in all this, given this definition of Open RAN, what's going on? How do you approach this at Deutsche Telekom?
So first of all, when we are talking about power efficiency, for us, it's very important also to what kind of comparison we have. And we compare our O-RAN and power efficiency with our traditional RAN. And what is important is when we are talking about our traditional RAN, we are talking about 4 radio access technologies, which we have still in our network, 2G, 4G, and 5G. And so this we have to compare and make sure that our O-RAN is as power efficient as our today's traditional RAN. And I also, if I see the poll which you have done, I couldn't agree more to the audience what they said basically. So the minority was that it is yet more power efficient than a traditional RAN solution. And a lot say, okay, it depends. And it depends from different aspects, from configurations, also from topologies. I guess that we will elaborate later on today. And yeah, let's have a more detailed discussion on this.
Yes, so let's get started. So if you look at Open RAN, and an alternative that an operator can be looking at right now. So there is an operator like Deutsche Telekom, but I'm not talking about you specifically. You have an RFP, you want to have a new RAN, and the parts of the equipment are pretty much the same. The vendors might even be the same. So how is it that Open RAN would be different in terms of power efficiency? What are the dimensions where Open RAN would be different than traditional RAN? Who wants to go with it?
Okay, maybe let me start. So yeah, so it's important to understand what the key characteristics of the Open RAN. Yeah, so that should be the starting point. If I give you the key features of the ORAN or Open RAN is number one. Once again, it's all about the open interfaces. And number two is it's a RAN intelligent controllers that we introduced. So and the third one is virtualized, cloudified RAN architecture, and the first one is a multi-vendor interoperability. So those are the key features. And on top, we have layers, software layers called the SMO, Service Management and Orchestration Layer, where you are running kind of orchestration and automation functionalities. So with that in mind, let me just say, you said, sorry, and yeah, so all 5 features that I just mentioned directly or indirectly to the energy efficiency or energy consumptions. But however, once again, back to the ORAN Alliance, what we are doing, we are the standard bodies. We do not explicitly work on the standardization of energy efficiency per se, but we do provide the tools that I just mentioned that can help make Open RAN system more energy efficient. So the tools that I just described in SMO, RAN intelligent controller, even open interfaces, and cloudification, virtualization, centralization of the resources, etc. So, but then it's up to hardware, software vendors and chipset makers, and most importantly, and also it's up to the operators to use these tools in their product development, in their network planning, operationalizing, and make their system energy efficient. And so, for example, let me give you an example. So let's say you have very innovation ideas in improving the RAN energy efficiency, right? So let's say you want to implement it, right? But then you have many options to implement it. You can develop on the traditional systems, right? Which tends to be a more proprietary, closed interfaces, single vendor configurations. Anyway, it will work because you implement it. So, but it works only with that specific configurations and specific vendors. But if you implement it based on the standardized interoperable platform, which is the Open RAN, your ideas will be implemented, once, but then it will be able to run across multiple vendors, thanks to the portability and also open interfaces. So this makes, innovations and their lifecycle management much faster and easier. So, so what I'm saying is the Open RAN toolbox is especially much more useful for things like such kind of innovation ideas, and also recently the AI machine learning based energy efficiency innovations. So that's,
absolutely.
that's my perspective.
Let me take a sort of a pause here, or a pause. We have Joe Madden that asked about how do we define energy efficiency, and I want to take that question, but I don't want to get stuck too much into that with that. It's a crucial question. How do you measure efficiency? And he's just gigabit per watt. So bit per consumption, unit of consumption. And yes, that's a good way to go. However, how do you define it? You define it on a per site base, on a per network level. So even if you do, this is sort of a standard way to define the efficiency. The question is that you define it over what? And in what circumstances? So and you can have it at energy efficiency at max, at usage over which period of time. So there's all sorts of ways that even if you define it that way, it's still not a single number that you can necessarily get out of it. And I don't know whether you want to have any additional insights into that.
Yeah, I mean, maybe let me get it. So to measure the efficiency is always hard. I mean, you have different possibilities. One is, of course, you analyze paperwork and to have here a comparison also between, again, between the traditional RAN, between the new ORAN solution. But the other one is to see it really in live network conditions under certain configuration, and that's really then hard to compare it in terms of transmitted gigabit per watt. So here we have a more a general approach really to see, okay, what is the site configuration, how many frequencies of I have at the site or at the site cluster, and compare this always before and after we do some changes. And you will never ever have the same traffic amount. So that's quite hard really to find here the right balance. You can have it theoretically in the lab for a certain frequency or certain conditions, or then, and that is the third element, which we have then really in the golden cluster in the network to compare it.
Absolutely. So yeah, so
time is
another dimension. So yeah, Alex, go ahead.
Yeah, I just add my comments. So, and there are industry efforts trying to standardize this energy efficiency metrics. For example, ETG, European standard bodies, and even 3GPP, they already discussed about this topic, the definition, clear definition of network energy efficiency. And they published some, what can I say? It's a specification or a white paper. So it contains 3 metrics. One is network energy efficiency, in short, NEE. And there's another metric called site energy efficiency. It's a SEE. And then they also have a third metric, which is coverage and capacity efficiency, called the CCE. These 3 energy efficiency metric is probably the something that we should apply. But however, as Gorden mentioned, it's quite tricky to be able to even measures all these energy efficiencies due to the complexity, operational complexity, different configurations, and different vendor landscapes. So yes, we do have some kind of a common standard, common understanding about this, and have 3 energy efficiency metrics defined by both ETG and 3GPP. However, the industry has to make more effort and be more practical and realistic.
Yeah, and this is actually quite important, because in terms of operators being able to meet their targets, they need to be able to measure what they have achieved. And so I think it's more than it's not a sort of academic discussion. It also has some impact in terms of how you track what you're doing for potential regulatory regulations, or just communicating or benchmarking your performance compared to others. So now let's go to the open interfaces. And what I sometimes hear from people that are not so much on the Open RAN side is that if you do have a RAN, which is a single vendor RAN, you can optimize power consumption because the single vendor has control over everything. So you can optimize better. So my question to you is, do we lose in terms of the ability to optimize the energy efficiency if you have a disaggregated multi-vendor RAN?
So maybe I start.
Go ahead.
Alex, if you allow.
Please.
So what we see and have seen so far at the beginning, or we are in the beginning of the ORAN introduction journey, that at the moment and the overall monolithic solution provides still a benefit when it comes to energy efficiency. And but what we see is how fast the development is now in the ORAN community and the ecosystem. And as you mentioned, the open interfaces, it drives innovation, and the innovation cycle on the chipset side is much faster than on the general purpose chipset side. So that I believe that over time, the openness and the power of the ecosystem will have a benefit, that even much more resources are going into it, and will help one of the most critical things, the energy efficiency in the radio network, to reduce.
Yeah. If I add on, build on top of it, the benefits the incumbents have over the Open RAN ecosystem is, thanks to their experience and the global deployments, they tends to have a better understanding about the end-to-end perspective. So when it comes to the performance energy consumption, this is a typical trade-off. So the solution, ultimate solution, always boils down to, you have to look at it in an end-to-end perspective. Component level, you can compare it, through the benchmarkings. Vendor A, base station, or the chipset is much more energy efficient than the others, and etc. So you cannot simply just collect and combine all these benchmarking tests from the component level, because the beauty is always on this orchestration level and optimization level, and optimization, orchestration, and automations. So the incumbents, they have these advantages, end-to-end perspective and optimization and orchestration and automations. So that's true. We have to admit that, but that doesn't mean that Open RAN communities cannot catch up. So as Gorden addressed, the pace of the innovation cycle is much faster in Open RAN community. So very likely they will catch up, and they will surpass the traditional vendors and properly tackle this trade-off problem. So their operators' involvement, operators' role is going to be critical. So it has to be a joint effort between the Open RAN vendor community and innovation communities, including the startups and also operator communities. So if we collaborate in a way that we drive these innovation cycles much faster, then I feel very confident Open RAN community will eventually be the more energy competitive.
Good. I guess now we lost Monica here.
Yeah, it looks like Monica is going to rejoin as soon as she can. She's having a little bit of difficulties, but if you guys can continue the conversation, she'll be rejoining shortly.
Yeah, but we have here also this question in the chat regarding the RAN ecosystem, and if the RIC and the innovation and automation, innovation and machine learning as main drivers for energy efficiency, what is the key, would be a key differentiation between traditional and ORAN vendors? Maybe we can pick this up. I mean, we have shortly already discussed this. But here also we have, from my perspective, to see what does it mean? I mean, this chipset and this cloudification, I guess that will come even on ORAN, or if you have a cloud RAN solution where a traditional vendor could built on their RAN compute stack and their radio optimized. So there are different flavors which we have to see, and I guess both is possible, but especially due to this open interfaces and the RIC, and I mean the RIC is kind of enabler for these applications which hopefully will come, especially on the X apps solutions. I believe that this will bring a huge differentiator, and that this can have a good influence. However, what we see is that usually if we compare a radio site, that 10 to 20% of the energy is on the CPU side, and 80-90% on the RU side. That means solutions which help us to reduce the energy level on especially on the radio unit, has the biggest impacts. And here, I guess this RIC and this X-ups can play a major role if we are able on this introduction cycle below 1 second to reduce the power on the RU side and to bring it up again quite fast. That this has a major impact and can help the ecosystem to be much more power efficient than we are today. That's my view, Alex. I don't know.
Yeah, indeed. Yeah, very good answer. Yeah, in my opinion. So the RIC is, I wouldn't say it's really a game changer. Rather, it's a kind of a platform for innovations. It provides real-time network intelligence and control, and therefore it empowers to improve the energy efficiency in many different ways compared to the traditional systems. For example, the RIC dynamic power control features enables base stations or DU to adjust their power levels based on real-time traffic conditions. This is important, the real-time controls, which reduce energy consumptions during a low traffic period. And another example is, traffic management. So the RIC excels at traffic management, optimizing network resource allocation and traffic routing to avoid the congestion and unnecessary transmissions. And the other example is RIC is it's a good platform to do the most optimized way. Load balancing and distributing network traffics across different DU or DUs to reduce the energy consumption. But that's not all. RIC also can employ many other features like a cell sleeping, and also it uses the network slicing, which is a key feature of 5G and standalone, and it associates network slicing to create the network RAN slicing, radio access network slicing with a specific energy consumption KPI, and allocate the resources accordingly. So in that way, I mean, if I give one more before we see Monica back, the RIC intelligent antenna optimization features will improve the signal strength and coverage by optimizing antenna placement and orientations. Once again, this will reduce the energy consumptions, or alternatively, you can say increase the energy efficiency. So AI machine learning technologies contribute to enhancing energy efficiency with the RIC through the RIC platform, and using many dynamic network optimizations. For the many dynamic network optimization issues, AI machine learning algorithms running on RIC platform will be able to optimize all these network parameters in near real time, or real time based on traffic conditions. So maybe what else? Yeah, AI machine learning can also develop optimize the energy efficient network protocols, such as waking up a radio and the low power modes. And that also can be used once again, massive MIMO, beam management, and etc. So those are the tangible examples that how the RIC platform can support this the enhancing the energy efficiency in the open RAN systems.
So sorry guys, I am back.
You are back.
Zoom decided to kick me out, and I couldn't. The whole IP address was blocked. I've never seen anything like that, but I'm back. But I've not be able to see the old questions. But I know you guys, it looks like you've done a good job at addressing the old questions. So what I would like to ask is there any old question that we haven't addressed yet? I don't know what you were talking about when I was gone, but if there is any question, then maybe we should take that. And then I see that there are some more coming up from the audience.
Yeah, there is a statement, no? Aren't the major OEMs also implementing the same optimization features? And I guess, yes, of course. I mean, these optimization features, that is nothing really specific to ORAN. That can also be implemented in a single RAN solution. But especially this RIC and the X apps and the openness and the additional possibilities to get in also for smaller companies, innovative solutions will help that, I guess, this open source solution will become dominant and have a benefit.
Yeah, I just seen one very good point, good comments from Robert Golowski, and he says a cloudified RAN comes with a new paradigm shift where you don't try to prevent the failure, but rather, let it happen and try to deal with it with, for example, pod recreations. This approach would reduce the redundancy, therefore enhance the energy usages. Absolutely correct. And this is the biggest, shift from the traditional approaches versus more cloudified or cloud native approaches. So there is a notion, famous notion in IT or cloud industry, that we should treat all workloads as cattle rather than pet. So in that sense, the traditional solution we can call it a pet, like a cat and dog. So and we have to evolve to the cloud native. So we in Open RAN, this will be the best. What can I say? Could be the best platform where you start to treat this workload, network function workload as a cattle. So without any names. The cattle, they don't have names.
Yeah, I think that if you look at sort of the general overran, and I hope that you didn't go over this already, but the whole overrun mindset, the openness, requires generally a new approach to energy efficiency. And it's an approach for which we do not have a solution today. And it's going to take time to require. So for instance, if you look at, and I was talking yesterday to somebody about optimizing through our apps, through the RIC, that there is an opportunity there, but we cannot say that we have a solution ready to deploy commercially tomorrow. And so what might happen is that the energy efficiency of Open RAN this very moment might not be what is going to be 5 years ago, 5 years in the future compared to the alternatives, but that's the kind of path you need to go because that's what innovation takes. You know, it takes an effort and it takes some time to develop. So, so you might be in a situation where, yeah, a single vendor solution today might be more efficient, but that's a fleeting type of advantage. So we need to look at the what is going on today and what is the opportunity. And I don't mean in a sort of really broad and sort of like that's kind of that's how innovation happens.
Yeah.
Right.
Monica, let me pick up another interesting questions from the audience.
Yeah.
So the question is, do you believe inline accelerators are required to achieve power efficiency from Open RAN? Short answer from my side is yes, because inline accelerators has two big advantages. One is much more customized. It's a customized silicon, so with the general purpose processor inside. It's an ARM processor inside, so it's not the same ASIC, you know, as before. It's more like literally it's an accelerator, but there is a general purpose processor. You can program it, you can download it, you can update your softwares. So that's one huge advantage, is to have the inline accelerator. The second is, you know, because it's inline, it doesn't consume any CPU powers at all. So therefore you can save a lot of CPU cycles. So that's the beauty of inline accelerator compared to the look-aside accelerator. So my answer is yes, it will save a lot of power, increase a lot of power efficiency. But then do we have the real number today? Unfortunately, all these inline accelerators, you know, it just came out from Marvell, Qualcomm, and etc. So it's the real, can I say, the benchmarking is remains to be seen. But I have a hypothesis: inline accelerator will give the highest power efficiency compared to either look-aside accelerator or GPP only, you know, processing.
So let me follow up on this, because I think this is going to be quite important. So there is clearly, you need an accelerator of sorts, but on the other hand, you can also have a dedicated chipset that doesn't technically require an accelerator, or basically the accelerator function is built in. How is that going to play in terms of having, you know, more dedicated chipsets?
Yeah. So in general, I mean, as Alex outlined, so this acceleration saves power. Yeah. And also depending on the configuration which you have, for certain configurations, like a huge site configuration where you have 3 low band frequencies, 3 mid band frequencies, and on top the C band frequency, you cannot work without an accelerator because you simply have not the CPU power. So there it is given. And also for this smaller configurations, what we have seen already in our assessment is that here the acceleration brings tremendous power savings. And we will also see this and review this in our lab measurements in the future, and really to see where are the differences between, Alex mentions a different ecosystem partner who is really there, the one which is mostly optimized for the software stacks from the OEMs.
Now, another dimension is the centralization. So you might have a RAN, and I guess even within Open RAN, you might have an architecture that is more or less distributed, centralized. So if you have a sort of more distributed infrastructure, there is more energy consumption at the site. And clearly, if it's more centralized, you can take advantage of the pooling that would make your network more efficient. On the other hand, that might also increase your front haul or your transport cost. So, your transport volume and therefore power consumption. So it's sort of like it's a trade-off. How do you look at that?
Mm-hmm.
So is it better to have more consumption in a centralized location and pooling, or have it more distributed and less transport energy consumption?
Yeah, Monica. So I will take it to your questions. Before I start give that answers, let me just come back to the comments Gorden just made. With regard to the necessity of the accelerators for different configurations. This is a very, very important. You don't need to overkill with the accelerators for those use cases which doesn't require complex complex systems, because many deployment scenario, you probably, especially in the early stages, probably 2x2, 4x4, 1 or 2 bands and much less capacity. Probably it's a good starting point. In that case, you don't need to accelerator, because accelerator tends to, it's an expensive silicon, and the card is also there is a cost associated. Therefore, as if possible, the recommendation is always to avoid to use the expensive accelerators. But there is a certain configurations, threshold, and beyond that threshold configuration, no way you have to use the inline accelerator. Otherwise, energy efficiency will dramatically become poor because of the complex deployment scenarios and complex frequency band of management. So if I give you a concrete example, once again, if you look at this energy efficiency white paper published by the ORAN Alliance, for example, 64 MIMO cases or radio unit, their estimation tells us the yearly energy savings is about 2,519 megawatts. Whereas if in case of 4x4 MIMO, the estimation of the yearly energy saving is only 876 megawatts. So the energy savings, energy efficiency saving, enhancement all depends on the configurations Gorden just mentioned. So that's the yeah. I just want to make a clear point on that. So don't overkill your systems with adding too many components or silicons or even complexities. So it all depends on. That's why I'm saying operators' strategy and their deployments schedule, and with the vendor management strategy, we should combine all these factors together, and then you get the energy efficiencies.
Yeah, and in fact, there is a comment here about inline accelerators not being efficient in traffic, in lower traffic conditions. And I think that whatever configuration you take, it really depends on what is the traffic condition, what is your ability to sleep, to switch things on and off depending on traffic. So it's not necessary, whether you need them or not, but there's a lot of ways in which you can deploy and network situations.
Monica, maybe we come also back to your question regarding centralization, because I guess that's also a key question, and everybody is somehow looking into it, what we can centralize, how we can centralize, and also the difference which we see between brownfield approaches and greenfield approaches, which I see as very important. So first of all, when we are talking about centralization, that is what we can centralize. Is it the DU or the DU as a CU, or the DU and the CU? especially to centralize the DU, we have the link budget, the latency budget, so that you are limited to 32 kilometers, which makes it quite hard to centralize DU and CU at the same time. That makes only sense in metro networks, and if your network topology is already designed for it, which it's more from greenfield or easier, which you start from scratch than from a brownfield. Another aspect first we have to consider is also 2G, 4G, 5G. So for instance, the centralization of the CU or separation DU-CU is only specified for 5G and not for 4G. That means if you want to split it and want to have the DU at the cell side, for instance, and the CU at the central side, you have to see if you have a proprietary solution from your OEM that allows you to do the split. So that are first some basic rules which you have to consider before you come really to the point, okay, what are now the power saving potentials I can gain? And I mean, we have also analyzed it quite a lot. Pooling gains, especially on 5G only, is at the moment quite hard to achieve. Especially if we're talking only about centralization of the CU. And in context as well, as you mentioned, that you have this higher transmission costs, the SFPs which you need, which also needs power. So if you all in all considering that at the moment we see the centralization approach is quite hard to achieve.
Yeah, absolutely. And so there's so many things going on. Alex, do you want to comment? We have a lot of questions. I suggest that the ones that are not specific to energy efficiency, we'll have to postpone. But I don't know whether there's any that you'd like to. Yeah, go ahead.
I want to pick up the last one. It's from Jed Burberry. It says, what about the cost of front haul and DWDM? If you don't have a fiber, can you centralize the DU easily? Of course, if you don't have a dark fiber, it's not easy to centralize. I mean, you have to invest on fibers for sure. So, but then what I want to address is the importance and the relevance of the transport layers on the energy efficiencies. You know, definitely transport layers plays also very as important as other parts of the network, radio access network, especially the efficiency of transport network can directly impact, and therefore it's always important to choose the right transport technology and configurations, and considering a lot of the distance limitations and the limitation of the geographical spreading or distributions and the capacity and coverages. What I want to set is ORAN Alliance defined what's called ORAN 7.2 interfaces, open front haul interfaces. But then if I compare this with the traditional one, not the CPRI, but the eCPRI, and both are front haul interfaces, but there is a difference. Open front haul, ORAN 7.2 front haul is we use much lower layer functionality split between the BBU and DU and RU, so allowing for more centralized processing. So therefore, it's more energy efficient and bandwidth efficient than eCPRI. And of course, eCPRI is also a relatively newer front haul specification. There is a major enhancement compared to the legacy CPRI, which is a CPRI, and because eCPRI, because you are adapting kind of a packetized transport, between the CU and DU, definitely it will significantly reduce the required bandwidth between RU and CU. Therefore, because of it, also enhance the energy efficiencies. But we believe open, ORAN Alliance 7.2 open front hole is gonna outperform the EC3, when it comes to the transport energy efficiency perspective.
Now, we talked a lot about, well, mostly about the equipment, the network, but there is also how you run the network, the operational side of energy efficiency. And do you want to comment on that? Because there is more than just getting equipment that is power efficient, energy efficient.
Yeah, of course. Once again, I mean, this is important, the end-to-end perspective, end-to-end based resource orchestration, optimization, and automations. So, once again, I have to highlight the SMO layer, standardized by the ORAN Alliance. So that's the role of the SMO and combined with the RIC. So this tool is geared toward for exactly the point, Monica, you just mentioned, operational aspects.
I cannot agree more. So that this combination and also the efforts and the openness will have to push it, and then you will see hopefully a really efficient ORAN solution.
So let's go back to the initial question and let me ask it to you. So is Open RAN going to increase the power energy efficiency in the RAN?
Yeah, I mean, we should do one more second survey, right?
Yeah, but we wanted to have your view first, because we want.
I mean,
let's just sum it up.
Yeah, the first survey, I think all the audience, I mean, their understanding is very accurate, in my opinion. So it depends, because we just threw so many variables and factors that needs to be considered, So so my conclusion is, yeah, it depends. It depends, but if you properly use all these new tools from the ORAN Open RAN specification or practices, then very likely you will be able to achieve highest level of energy efficiency.
Gorden, how about you?
Yeah, so for me, of course, also it depends also on the timestamp we are looking into it. So if we're looking today and what we have seen, so there is still a way to go for ORAN. But if we are going 2 years in advance, in the future, I believe then ORAN has a good chance for a lot of configurations to be a real, also from the energy efficiency point of view, a solution which is operatable for every mobile network operator.
Okay, so now we're gonna ask the question back to you to see whether anybody changed her mind. So Kendra, how about showing the second poll, which is the same as the first one?
Okay, asking again, is Open RAN going to be more efficient than traditional RAN?
And so we'll see, and I think that's really the whole energy efficient is something new. So and Open RAN is new as well. So it's no matter how you answer to that, it's a complex but really fascinating question. And I guess that for you guys that are implementing it, I think that it's a lot of discoveries that you're doing. You're a lot of things you're finding out as you go along doing it. Okay, so let's just see, Kendra, what is that our audience found out the things.
Okay, we have 53% now say it depends. 31% said Open RAN is more efficient, 17% said Open RAN is less efficient, and 0% said I do not know.
So I guess we got 10% of the people that didn't know that now they know. So that's all. Any closing views for you guys?
Today, I mean, this is, I mean, very, very fruitful discussions, and I'm happy to learn that there is improvements with regard to between the two poles. So quite encouraging.
Okay, well, thank you, Gordon, and thank you, Alex, and thank you all in the audience for listening and contributing to the discussion. Kendra, thanks, over to you.
Okay, great. Well, that will conclude our webinar for today. Thanks again to our speakers and thanks to the audience for those great comments and questions.
Thank you.
A recording of today's webinar will be available on demand on the senzafili.com website in the coming days. And we have another webinar coming up May 2nd with Mark Gilmore, CTO of Connectivity, and registration for that will also be available at senzafili.com. Thanks again, and we look forward to seeing you at future events.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye-bye.